The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, everybody, and this is Dr. Mansour, and today is April the 19th. As all of you know, probably already got the news. One of you sent an email to me and told me about something that already posted on the website for the NCEES. I believe Ray, he sent it to me. Yeah, thank you very much. Yes, it is right now the October 2020 exam. They are saying that because of the cancellation of April 2020 paper and pencil exam administration impacted approximately 16,000 examinees. So to accommodate these examinees, the format of October 2020 exam administration will be modified as detailed below. So because of the number, and maybe new engineers will join, so they are going to split the dates. So they have exams on October 22nd and October 23rd, which is a Friday. Normally they give it a Friday, as you know. So in order to accommodate the large number of the engineers impacted by this COVID-19, so transportation, which is the one I'm teaching, is going to be on Thursday, not on Friday. The construction will be on Friday as originally scheduled. Obviously, geotechnical, those of you are going to take a geotechnical. I don't know if any of you here today. Those of you are taking civil, water resources, and the environmental. So the structure structure and construction on Friday, the 23rd, and the other three disciplines, the geotechnicals, transportation, and water resources, will be on 22nd. So check the website from time to time, and if you are aware of any updates or anything that you would like to share with your friends, that's fine. And if I came across any updates, and I will share it with you to make the maximum benefit. Or so the construction group, they have advantage one day, Friday. And the structure, they have the advantage of taking the exam on the following day. But transportation and geotech and water resources, they will be okay taking the exam, or the exam will be held on the 22nd, which is Thursday. So please make a note in your calendar that, and and this is a Friday. Just something that I was shared by one of you, or some of you send it to me. One of you send it to me, so I said let me share it with you. So I hope that everybody is healthy and everybody is. I did something very quick. Again, I'm really busy with tons of things around me. Um, this unusual situation making me a little bit busy with a lot of things. So I included additional two problems related to signalization or signal warrants. And I did not finish as the flow chart for the remaining. So I hope that you get a chance to uh, to um, solve other problems that related to warrants. And when I finish the flow chart, for sure I will send it to all of you. I'm really busy, so forgive me for that. And also the solutions for number 1 and 3 and 4, 1 and 2 and 3, the mini exams I send. I will be thank you very much, my friend. I really appreciate. Yeah. Our friend in New York is telling me how's everything going in California and asking about my health. Thank you very much, my friend. And I'm really worried about everybody in the States, okay, especially the people who are in the hotspot, New York and neighborhood, okay, Louisiana and New Jersey and all these things and all of the. So additional couple of problems, please look to them. Already we talked about that, but the flow chart, the one already I covered only warrant number 1, but I will do all my best to finish the remaining and problem number 3. I was reviewing something last night and I came across this problem. So if you look at it, let me see what. If you received it, that's good. If not, please let me know. Always email me. I try to email it to everybody who is on our mailing list, especially for those who are attending the free workshops. Um, but you are very welcome to email me if you missed anything, and I will do all my best. And also my assistants or the people who are helping me or my staff, they are working from home, as I mentioned before many times. They are working remotely because they don't like to come to the office, or I encourage them not to come to the office because of the risk of this COVID-19. So um, um, they are doing all their best. But if you go to our website, as I mentioned yesterday, they are loading the stuff on the first page. There is a window here. I tried opening it yesterday, but I couldn't go through to see how they arrange it. But it's supposed to be here under free workshop videos. I will try to search it and see if you are able to. I think they developed a YouTube channel for me for our business, and they list all the videos, the free videos over there. And you're supposed to get access to it. And if you have any technical difficulty, please let me know. I convey it to them. I don't do that. And they are helping me. So they are doing their best to load the videos as soon as they can remotely. And, and sometimes the computers, they shut down here, so I have to come to the office to turn the computers on or turn the internet on, or make sure that everything is still connected, because there is a lot of interruptions here and there because of the load on this internet, as you know. So if you look to this problem here, so go to our website, and hopefully that you will be able to get access to all the videos. And if not, please let me know, and I will do all my best to get in touch with them to see what is the issue. So if you look to this problem here, problem number 3, shown in front of you. If you did not get a chance to print it, no problem. It is here, and the when the PDF of the lectures. Oh yeah, the notes, we are behind 1 week, Muhammad. I agree with you. I will I will take, you mean my notes? My notes, yes, I'm behind 1 week. So yes, I will do all my best to scan it and send it to you. If you are talking about the PDF of my hand notes, yes, forgive me for that because it's really, really busy and nobody is helping me. So I'm trying to help as many as I can, as many as I can. Can you go over 32 of the AM and BM practice exams and solutions transportation book, problem 32? Okay, I will be glad to do that. Can you go over AM, BM practice problems and solutions in transportation book? Okay, sure. I will be glad to do that. Okay. So let me bring the AMBM book. Here it is. Problem number 32. Let me make it uh, um, problem 32 of the AM and BM book, but there are 32 of the BM and 32 of the AM. So this is, let me show it to you, Linda, and are you talking about, let me make sure that I, problem 32, this is 32 PM, and this is 32, do I have 32 for BM, for AM, sorry, 32 AM. Let me see if I have 32. No, I don't have 32 AM. So most likely are referring to 32 PM. So about the accident, the crash rates. If this is the one you are talking about, I will be glad to go over it, unless if you mean something else. Okay. So let me circle it, and I will be glad to. Let me make sure that I am. Yes. Okay. That's good. Okay. So you are talking about the same problem. Okay. So yeah, sure. I will circle it and I put it on the side here and tell. So the problem in front of you, number 30, number 3, sorry, number 3. Um, um, Let me give you a chance. Try to do your best to draw some kind of a diagram or figure or illustration, or let me get it closer as much as I can for those who didn't get a chance to. A horizontal circular curve to the right. Again, they are telling you the horizontal circular curve is to the right, has a radius of 1150. The intersecting angle at the center is given to be 36. A point C on the major chord is located 215 from the PC. Okay. A line connecting the center of the curve and the point C extended to intersect the curve at point D. Again, it's very, very important to translate into English. And I will give you 1 minute to draw it, and after that I will resume. Okay, 1 minute only. I need you to draw the problem as stated here, or as shown in the front of you, and see if um, we are going to get the same drawing or not, or are going to agree or not. Okay, so if we look to this problem and let us draw the problem. He said it's curved to the right. So if this is my back tangent, and if this is the beginning of the curve, PC or BC, both of them are used. And this is a curve to the right. So the curve is turning to the right with respect to the beginning of the curve. So is a curve to the right. Here it is. Try to use different color here. So if you are standing here, if the curve is turning to the right, so you have to draw it that way. If the curve is turning to the left, okay, will be the other way, which is this way. So sometimes the direction of the curve does not make any difference as far as the right or left. But if it's stated in the problem, the direction of the curve, I will do it exactly as stated in the problem. Okay, so we do have since this transportation BM, sometimes they come up with difficult problems. So this is the center, and this is the radius, and this is the end of the curve. So try to draw as much as you can during the preparation. This will help later on when you be on the actual exam. This is the end of the curve or point of tangency, PT. Sorry. Sorry, the allergy is bothering me since morning. I took the medication the night before, but still. As all of you know, this is the central angle delta. Most of the book they call it delta, but some books they call it I, because basically if you extend these two tangents, they are going to intersect somewhere here at a point they call it, or we call it, or the textbooks they call it the point of intersection, as all of you know, PI. This is a PI. And this tangent equal this tangent, as all of you know. And if you extend this, this is called deflection angle, which is also equals delta or I. But it is named also as a deflection angle. And as all of you know, the deflection angle is an angle drawn between two lines, okay? Two lines or two tangents or two courses. So this is the back tangent, as all of you know. Always the back tangent is associated with the beginning of the curve. They agreed to call the tangent before the beginning of the curve or the point of curvature back tangent, while this here we call it forward tangent, and also the forward tangent is associated with the end of the curve or the point of tangency. So the let me see here. That's correct, my friend. I will talk about this. Yes, that's correct. Thank you. Um, 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 so the radius is given to be 1150. And he said that the intersecting angle at the center is 36. Okay, this is he referring to this delta here with 36. This is what he meant. Okay, this is called the center, by the way, center. Other name for it's called radius point. Radius point. So if you hear or you see this term, radius point, they are talking about the center of the circle, because this arc is taken from a circle. Originally it was a circle like this. It's a circular curve. Sorry, this is a circle like an, but believe me, it's a circle, okay, and we took portion of it. And this, for example, or this portion, or this sector of it, or this arc of it, okay? So this is the central angle, which is the same as a deflection angle. And he said a point C on the major chord. What is the major chord? We have only one major chord connecting the beginning of the curve and the end of the curve. Major chord. So I connect the major chord by draw major chord by, or the long chord. So this is called LC, major chord, or simply C, by the way, or LC, long chord, or uppercase C, okay, or the major chord as stated in the problem here, major chord. Or long chord, or sometimes just we call it chord. The other, we call it subchord. Okay, we call it subchord. Okay, any other chords, so we have major chord, long chord, or chord. But if you do have a circular curve and he is referring to a chord other than the major chord, so he should tell you this subchord, assuming this is a curve. So if this is a subchord, okay, if this is, so a point A, for example, so this we'll call it subchord. And the subchord, he has to specify connecting what. So I have to, but the long chord, there is only one long chord, which is the one we talked about it, okay, which is connecting the beginning and the end of the so we have only one long chord. So if he said that the long chord or the major chord, or even if he mentioned just the word chord only without specifying, so if he mentioned just the chord length is without telling you a subchord, I always take it as the major chord. Okay, so I need to be aware of that. But here he said that, okay, so a major chord, okay, so a point C on the also uppercase C is the long chord, by the way. Okay, lowercase c sometimes we use it, okay, for subchord. So let me get rid of this C, at least we'll not confuse with our point C. I don't know why did I call it point C, but that's fine. So a point here along the a point C along the major chord is located, okay, 215 from the BC. So I have a point. So this distance is 215 feet. Okay. And he said that if we connect the center of the curve, okay, a line connecting the center of the curve to point C extended to point D, So we extend from here to here to point D. So far so good. And he's saying, what is the arc length of PC, the point of curvature, to D? So he's looking for this. Let's see if you agree with me or not. Here it is. This is what he's looking for. This portion here, this arc here. So he's asking how much this arc here. Okay, I hope that you draw it the same. And again, not every single problem that will be given to you on the exam will be drawn. Some of them, if you look to the NCEES, you will find that some of them are already drawn, but we need also to practice how to convert uh, this to this. So, and every problem, by the way, every problem, there are more than one way to do it. Some of them are longer than others. And this is why when you solve a problem, ask yourself, is this the only way or the only method to solve it? Because we need shortcuts. Shortcuts. Any shortcut or any short approach or short method to solve the problem, obviously it will be a plus for you. So let me give you a couple minutes to think about it. And when you read the problem, after you read the problem, and if you are able to translate it into English like this, so in this case, you need to think immediately after you translate it. What are the steps? Okay. Steps, procedure, if you'd like to call it whatever. Procedure or procedures or the logic, how I'm going to attack this. I need this arc. The arc length from the beginning of the curve to the point D. Okay. 2 minutes, almost done. And during the exam, as I mentioned before, or probably I will come back to this. So today is 4/19, not 3/19 as I did last week. I remember still insisting that we are in March, but our friend Muhammad reminded me last week, said, oh, this is April, not March. Transportation BM. Yeah, if you, thank you for. There are two important laws we learned them in high school. and we need to include them in our list of equations. You might need them. I will call them two laws from Trig or from any class. The law of sines and the law of cosines. Okay, we might need them. The law of sines, if you have a triangle like this, and this dimension is A, and this dimension is B, and this dimension is C, the length of each side. And if we name this angle here, whatever they call, some books they call it the same letters uppercase, some books they call it alpha and beta and gamma. Alpha, beta, gamma, it doesn't matter the naming as long as you know. And the law of sine say that if the dimension A, this side here, over the sine of the opposite angle, which is sine beta, this equals to dimension B over sine gamma equal dimension C over sine alpha. We need to know this law just in case. The other law, if we take the same triangle, and this is a dimension A, or the side A, and this is B, and this is C. And also let me name the angles to be alpha and beta and gamma. So the law of cosines say that if you take this dimension here, which is squared, is equal B square plus C square minus 2 BC cosine the angle in between, which is beta. The other three, the other two relationships, which is B square. Sorry, I remember to do something very quick. B square is equal A square plus C square minus A C cosine the angle between A and C. A and C, the angle is gamma. And finally, C square is equal to A square plus B square minus 2, sorry, minus 2. And this is AB, and the angle between AB is cosine alpha. Those are three laws, three relationships, sorry, relationships related to the law of cosines. So we need to pay attention to this. You might. Another thing that, by the way, since I draw this triangle, the one it has three sides, there is one equation, I'm sure that you saw it somewhere, which is the area. If you have a triangle with three sides and the area is required for this or such a triangle. So if this is A and this is B and this is C, where A and B and C are the three sides, so the area of this triangle, the area is equal to square root of S times S minus A times S minus B times S minus C, by the way, where S is equal A plus B plus C divided by 2, not divided by 3. So this is something that maybe you need such a relationship in one of the problems, either in the AM or in the PM. This is something that I needed to be aware of. Okay, so going back to the problem that we were talking about, the problem about the horizontal curve, sorry, not vertical curve. Sorry, I'm looking for something again. When I'm talking, somebody asked me something yesterday, and sometimes I remember things, so I try to about another course. Okay, so going back to this problem here, how can we get this arc? Or what is the approach? We do have an equation. We do have an equation given in our or in my books, but the equation you don't have to dig in, because this is a curve length L. This curve here length is called, I will call it L. If you take L divided by delta as the arc length we are looking for, divided by, I will call this as alpha. This angle I will call it from here to here. Let me call it alpha or beta alpha. Delta is known, which is 36. L, I can get L easily. Is this correct? What is L? L is equal to pi r delta over 360. And again, this relationship, I know it. Because if you do have a complete circle, and this is the radius, what is the circumference of this? It's 2 pi r. But in this case, the angle delta will be 360. 360 over 360 will cancel out, will give you L is equal to 2 pi r, which is the circumference. But if I took only a portion of this circle, here it is, an arc, and I will call this as L. So delta, so I proportion delta with respect to the 360 multiplied by 2 pi r. Again, an equation, you can figure it out. So this by proportion, and this is by proportion. So L is known, delta is given, arc length, this is unknown. So alpha is a key for me. If I'm able to get alpha, became piece of cake. Agree or disagree? If this is one approach, and after that I will ask you, is this the only way to solve a problem? So I need you to think this way during the exam. What is the logic? The shortcut, steps, procedures. If you call it logic, I have no problem with that. Or approach, if we're talking about signalized intersection approaches. So if you like to call this is, what is the approach? Can we get alpha? I know from here to here, which is the radius also, which is 1150. Something very important you should know. How much is this angle from here to here? This is 90. Do you agree with me? And this is also 90. Because a tangent to a circle must be perpendicular to the radius at this point of tangency. So far, so good? If you disagree with me, please let me know. This is one thing. The other thing I needed to be aware of, that this angle from here to here and this angle from here to here, these two angles are equal because the two tangents are equal, and each one of them is called delta over 2. So this is also delta over 2. This is delta over 2. So this angle here is what? If the entire angle is 90, and this is delta over 2, so this is 90 degrees minus delta over 2. Since I know delta is equal 36, so 90 minus 18 will give you an angle. Is this correct? Which is 72 degrees. 90 minus, yeah, 72 degrees. So how can I get alpha right now? I know this length, and I know this length. I don't know this length yet. CO or OC, from here to here, I don't know. I know from here to here is the radius, yes. And I know this is the angle alpha I'm looking for. I'm looking for this. And thus, obviously, this angle here is 180 minus alpha minus 72. So how can I get alpha? I'm still looking for alpha. In order to plug it here, because I know L, and let me do L very quick. We can do it together. Equal 2 pi R. R is 1150. Delta is 36 divided by 360. So let me do this very quick. And this L here came to be, so 36, so it is 10 in half. This is 36 degrees. So 1150 to, and by 10 divided, so it is 722. I got 722.57 feet for L. So I got one step. So this and this, I need to get alpha, and from alpha I can get the arc length. And there is one equation, let me show it to you on my book in chapter, different chapter, the chapter 1, I believe, of the AM. Series of equations here at the beginning of my book. This is the transportation book, by the way. This is, I'm referring to my transportation book, the 3rd edition, and specifically on page 12. If you look at it, the relationship between, in the class we covered that, the deflection angles, central angle, and chord calculations. And here you'll find equations. The deflection angle is equal to the arc length L delta over 2. Here is delta over 2, by the way. And the arc length times 180 over 2 by R. And this is the angle alpha. Okay. The central angle is 2 alpha. And 2 alpha. So we have all these equations. And the chord, also the chord length. This here, the chord length, I meant here the chord from the beginning of the curve to point A. This is, I will call it subchord. So at least to make sure it's not the long chord, subchord, because the long chord is given on the previous equation, previous page, sorry, as LC or uppercase C. If you like to call here also, this is a major chord. This is on page 10, by the way. Major chord, I have no problem with that, of the same book. Major chord, I have no problem with that. Okay, but here are the equations that we are talking about. Okay, or very close to what we are talking about. So right now, we are getting close. I need to get alpha. If you let me draw something, one more drawing. Obviously, on the exam, you don't need to do all this. If you look to this triangle and tell me what do you think? If we can use anything that we learned this morning, or we remember this morning, or I reminded you with this morning, will be good. This I will call this is O, which is the same as the center. And I will call this point C. And I will call this is a PC, or the beginning of the curve. This is a 215 feet, by the way. And this is the angle that's 72 degrees, which is 90 minus alpha over 2, minus delta over 2, sorry. And this is the angle alpha I'm looking for. And I know the radius here is 1150. And I'm looking for this. This angle here, I don't know it, by the way. Do I know it? I know it is 180 minus this here is 180 minus alpha minus 72 degrees. But unfortunately, I don't know alpha yet. So I believe I draw, let me just make my camera a little bit wide to show you the whole story. Any suggestions to get alpha from this triangle here? Let me give you another minute to think about it and you try to find it for me. If you found the angle alpha, bingo. I will come here and plug it into this, and I will solve for the arc length, and after that we'll come to the equation, the question I ask. Do we have another way or a shortcut to get it? Because I need to get all the shortcuts. Sometimes I solve problems a little bit different from, sometimes I think when I solve it differently, but I solve it probably sometimes to show you many steps in order to cover all the steps, just in case if there is intermediate step, it could be a target for a question in the morning, in the future, sorry, not in the morning. Okay, so let me, one of you already raised the hand, or okay, L, we get the L, that's correct. And our friend, he gave an answer. Muhammad, he said that, oh, I should mention the name, by the way. One of you mentioned that the answer is something. Okay, we'll wait until you see if the answer. Alpha is 5.36 degrees. Okay. No, I disagree with you. Okay. And both answers, some of you give me both some answers. We'll see if if the answer that you got is matching the answer or not. Okay, so the two laws I just mentioned, the law of cosines and the law of sines, I need you to remember them because they might help you in the future to solve some problems either in the AM or specifically the PM. Okay, let me write, this is good S here, S. Let me see here because I could scan this and send it to you when I finish, and I will do all my best to scan all the previous notes and send it as soon as possible. Okay, if I know one side, I know this side and I know this side. If I know one more side, which is this side here, because this angle is known. You remember this angle 72, it came from what? From 90 minus delta over 2. Remember this. This is a very important angle, the one I found here, okay, which is 72 degrees. So if I can find this, OC will become piece of cake because I can use the law of sines. So I will apply the law of cosines first. I will say OC square is equal 215 square plus 1150 square minus 2 times 215 times 150 cosine 72 degrees. 72 degrees. Do you agree with me that this square is equal this square plus this square minus 2 times this time cosine the angle in between, because I know the angle in between is 72. This will give you OC. Anybody can give me the OC? Can you read my Egyptian handwriting? Sorry, sometimes I try to improve my. Back home in Las Cruces, when I was doing my PhD, we have a professor, his name is McPherson. I wish one day I told him, I need you. He taught me, I took about 10 classes with him. He is the most wonderful professor I have ever had. The teaching methodology, I learned a lot of things from him. And the most important thing that I tried very hard to learn, or another important thing, it's not the most, is his handwriting. Unbelievable. I told him, Dr. McPherson, I need you to teach me how to write this. And intention, I told him, I'm willing to pay you. Just teach me what technique do you use to write this nice. When you go to the classroom and the blackboard, during this time we're using chalk. Probably you know exactly what my age right now when I say using a chalk before the markers and before the cameras and all these things. You might guess how old am I, but I'm not going to tell you. Anyhow, so it is every little tiny space on the board is used, and in a very nice handwriting and well organized. At the end of the class, I wish that we had cell phones at that time to take a picture of this. It is a piece of art. And in contrast, other professors, believe me, you don't know what is in the board. From the sloppy work, every corner has something different. And so I try to learn as much as I can, and hopefully I can write a little bit better than the Egyptian sloppy you see in front of you. So what's OC? I got OC, let me see here. I think 72 cosine and 1150 times 215 times 2 times and 215 seconds square, 1150 seconds square plus, and recall C and minus, and take square root. I got something different. Minus 2, something, okay, 72. Yes, it is 1102.9 feet or 68. So I got that. I hope that I did it twice. The first time I got it something very strange. I said, there's no way. So right now I can apply the law of sines. This is the law of cosines. Law of cosines. The law of sines, it says that this side, which we just found, which is 1102.9, divided by the sine of 72 degrees, as this side here, which is 215 feet, over sine alpha. This, and in this case, I will solve for alpha. And this is the whole story. So 72 sine and 215 times and 1102.9 times, and I will say inverse sine. You have to do this very quick. Okay, very, very quick. Okay, one more time. 72 sine and 215 times inverse 1102.9 times and inverse sine. Anybody get an answer for alpha? Okay, I did it 3 times and this the same number I came 10.69. 10.69 degrees. I'm rounding. I will take this 10, this angle here, 10.69, and plug it here, 10.69, and this is 36. And what is L? L is 722.57. Now, the only missing piece of this is arc length. Do it for me, please. So it is 10.69, here it is, and 722.57 times, and 36 divided. I got from here 214.49. 0.49 feet. And 214.92, 213, the closest one is B as in boy. Probably if we carry more decimal places, or maybe I put the answer here. $214.49 or 0.5. So the closest answer is this one here, which is B as in boy. Makes sense. Any question about that? Maybe the answer could be adjusted to 114.50 or 0.49 as I got. Since I carry all decimal places, probably it could be a typo, but this will be my answer that I will select. But it is a good problem, and I hope that when you receive this and you review it, you will say, oh, there is another shortcut, there is another way, and we can solve a lot of things, by the way, related to this. Okay. What about if he asks you the distance from here to here? This could be another problem. The distance from here to here, CD. If this is, let me put C closer here. We can generate it. We can generate or a lot of problems. CD. How much CD? If he asks you, same problem, ask CD. It will be a good idea. I can include this in the problem later on. It could ask you what is the subchord between this and D, which is this line here. Another question. Subchord. Do you know what? I will take this problem, I will modify it, and okay, subchord. So please look to this, and for those of you who solve the problem and give me different answer, please let me know if I did a mistake or I did an error or why your answer is different from mine, and if there is a typo or a mistake from my end. Okay. CD. CD is equal. Now look at again. Look at again. Okay, the angle alpha 14, 10. Okay, so we are getting very close. 10.69, 2.68, 10.7. All of these are good answers. And okay, look at it, and I will do my best to. So let me do one thing today because I have to do it. I will scan it before I go home. Even I know I will scan it before I go home and send it to you. The lectures and the notes for at least I will catch. At least you can, I will do that. I will do that. Okay. The problem that since already I solved it here and probably my handwriting a little bit better than before, so probably I will scan this color and send it to you. So the angle alpha, let me put the angle alpha here. The angle alpha is at 10.69 degrees. And as I said, please, when you receive it, review it. And I need you to think about this. Is this the only way or the only method to solve it? Do I have another shortcut? I can get this arc length instead of doing all this calculation. Sit together, sit and think about it, and we need to do that. And I will come up with other problems, okay, related to this problem here. Let's go to the problem that one of you asked me about from my book. Where is the book? Here it is. Problem 32. If you don't have this book, I would be glad to make a copy, at least to send you the problem. Um, uh, um, it is observed that 50 traffic crashes occurred on roadway for a length of 20 miles in 1 year. The average daily traffic of this road is 60,000. The crash rate per 100 million vehicle miles on that road, which is a rate of 100 million vehicle mile per 100 million. Okay. The accident rates or accident calculations um, accident rate or accidents rate. It could be related to intersections, like the problem. I believe the NCEES, they have a problem, and probably we talked about it in the class. Let's see if I have here. Here it is. You have an intersection, problem 508 of the BE Civil Engineering Transportation Practice Exam, the Blue Book by NCEES. During the month of January to September, which is 9 months, the ADT of the intersection is given, and the accident rate per million, not but 100 million, but per million vehicle of this intersection. This is the equation, the rate per million vehicle entering is given in the section or the chapter of my book. We'll talk about accident analysis, and let me locate it very quick. And as we said that the accident, I believe they are at the end of chapter. Let me see here. I can get located very quick. Sometimes and the index sometimes, if, as I said, that if you're stuck with something, traffic safety, and we use this equation more than once, and I believe we covered it in the class, if I remember correctly. If not, let's see if I have the right book or not, because sometimes the accident rates, here it is. Let me see if I got the right book. In my textbook, the accident analysis and accident rate, the equation given for the intersections, I named it as equation 1-13, as the number of accidents times 1 million divided by the ADT number of years, 365 days per year. And this is the equation that I applied here for the problem 508. So the equation is given as the number of accidents times 10 to the 6 divided by the ADT times the number of years times 365 days a year per year. And this is exactly what we did when we solved this problem together. So 25 accidents, 10 to the 6. We added all these volumes, all the volumes entering the intersection. So it is 2,000, 8,000, 4,000, 6,000. I have 9 months, so 9 over 12. And the number of days per year, 365. If you like to use it, 365.25 as some books did, I have no problem with that. And we ended with 4. So this accidents analysis for intersections. So we are looking to the number of vehicles entering the intersection. And we add them up and plug it into the equation or do the calculations as I just did. So the number, so the accident per million vehicle, accident per million vehicle is equal to the number of accidents, as I mentioned. Let me write it down, times 10 to the 6 divided by the ADT times the number of years times 365 day per year. Okay. The other set of equations that the segments, roadway segments, we can calculate the accidents or accident rates, much better accident rates, and get rid of this S here. So in this case, we have 2 equations, and they are given in my book as shown here as equation 1-14 and 1-15, 1-14 and 1-15. The accidents per million vehicle or per 100 million vehicle. So 100 million you multiply by 10 to the 8 by million is 10 to the 6. The number of accidents, the ADT, the number of years, 365, and now the length of the segment is part of it. So the length of the segment must be part of the calculation because we are talking about a segment of a facility of a highway. So we have a segment. This segment, whatever the length is, L, and in miles, and we consider this segment from A to B, for example, and we plug it into the equation. So the second, equation, as I said, that is 100 million. This is just a million per million vehicle mile. So it is. So this is the 100 million rate of 100 million vehicle mile. So I will do the same thing, and let's see if we are getting. So it is 20 times 10 to the 8. If we're getting one of these answers, and the 6,000 is given. This is ADT times the number of years. He said that is only 1 year times 365 days a year, day per year, times 20 miles. Oops, sorry, you cannot see because I'm writing here to myself or what. So this is the way, according to this equation here, equation 1-15 of my book, or any book, they have the same equation. Maybe they write it a little bit differently. So 20 and 10 to the 8 and 6,000 divided, and the 365 divided 20 divided, okay, So let me do it one more time. 20 enter and 100 million times 6,000 divided 365 divided 20 divided. So I got 45.66. Okay, so I don't see any answer to match that unless I did a mistake here. Per 100 million vehicle mile and 20. Oh, I'm sorry. I did a mistake here. You see, I told you I am a human being. I do mistake like anybody. So I said that I picked that 20 miles twice. So let us do that. So it is 50. Enter because 50 accidents. Crashes 50. Enter 100 million. This, so I said that I don't have an answer. And the 6,000 divided and 365 divided to see if we're getting something any. Okay, so it is 50 and 10 to the 8 and 6,000 divide 365 divide 20 divided. Yeah, it is 114. 114.2. Okay, so probably this could be a typo. It could be a typo. So let me make sure that I did not miss anything. In 1 year, 365. So it could be a typo. It could be this is 1114.2. Let me look to my solution. Probably the people are helping me. Probably I review it myself, but it's still my fault that, or still I didn't catch this typo mistake. But we can correct it if there's a typo. Yeah, 114.2. That's correct. Okay. So probably I think the answer should be A, but the answer should be corrected here instead of this. So it should be 1114.2, and I will pick the answer A. So there is 1 0 missing from the calculations, and I will look to the solution to see if this. So probably this is what you meant, that the answer you got does not match one of these answers. That could be a typo. Okay, so I think I will review that. But this is so I will do that. Let me put a note here. At least I can look at it and see. To Okay, thank you very much. Anything that you can find, okay, especially when I come with the new editions, a lot of it changes. So, and I do my best to review all these things. There is another type of problems. I could include it in my next. He will ask you. He will give you the number of fatalities. The number of fatalities, and he might ask you the rate. So he might give you the number of, let me see if I have. Unfortunately, I don't have the binder here with me. The number of fatalities, and he will ask you to calculate, okay, the rate of fatalities per whatever is very interesting type of calculations related to accident analysis, and I will be glad to include some problems since you mentioned this. And okay, so this is something that I included also some of problems. Okay, I just want to make sure. Oh yeah, yeah. I hope this. Okay, the math typo or the typo is okay. I will look to that. I think there is a typo or math error, but the concept, I hope that. But the concept will be very clear because they can ask you about this. By the way, they will ask. They will give you a number of fatalities, and after that, they will ask to get the rate of fatalities. I will include that probably in the next mini exam. I included also something, we may have talked about it before, but, and I don't know if I send it to you or not, which is some mass diagram problems. I hope that we can go over them, but let's take a few minutes to break and come back, get some fresh air. Air clean from any virus, please. Okay, we need to get only fresh air without really getting all these. I hope that this virus is gone very soon. And so let's take about 10 minutes break. Right now is about 10:25. So 10:35 we'll meet again. Thank you very much. Okay, welcome back everybody after this short break. I found another two problems related to the accident analysis, and it does have one of them. It does have the fatality percentage, and they ask you about the rate of fatality crashes per 100 million vehicle. So this is a problem that it's in one of my books. Probably you have it. The transportation depth practice exams and solutions, problem number 36 of the first exam. I will also include this with the scan. When I scan it and send it to you, at least you have it, just in case if you don't have my book. So a 17.5-mile long segment highway had 40 crashes in 1 year. The ADT of this section is given to be 5,000, and it was determined that 5% of the crashes involve fatalities. So the first one, or the first problem, what the rate of total crashes per 100 million. So this is exactly the same as we did for the previous problem. So the number of accidents, 40. I picked the right number this time. Here it is. And the length of the segment, and we ended with this number. So this is very similar to what we were talking about before the break. The second problem, number 37, it is the rate of fatal crashes per 100 million vehicle per mile. So right now we are doing the same thing, except we multiply by 0.05. So the number that has been done before, or the calculations that's done before, we take the percentage of the fatalities that is indicated in the problem statement, and we multiply it by the percent. So this percentage, here it is, the percentage of the crashes involve fatalities. So this must be given to you. This must be given. Must be given. One day we wish to be zero, but unfortunately, some crashes ended with a fatality, and some crashes with just bodily injured only, or maybe. So we wish that all of them to be with no fatalities. Okay, so I will scan this and send it to you to strengthen your knowledge or increase your knowledge about this. I remember after uh, during the break, I remember I said I think I remember where they are, these things. So I try to. Okay, and also I think 2 days ago we received a shipment. By the way, long ago it was ordered. I don't know how many months ago. Or notepads. Uh, um, I use it as advertisement. To be fair with you, I send it to those who are uh, taking my classes and those who are ordering all my books. I said that instead of buying a notepad to write or solve the problems, and probably the color bad or whatever it is, I said that if we can coil it, so you can carry it with you to the exam. So if you have problems solved, and you can mark them here, and you can take it to the exam with you. So I came up with this idea, and I used to have the yellow note badge. Probably some of you remember that, for those who took class with me before. So if you are interested, I can send you one or two. It's 100 sheet, about 100 sheet each. It is grid. Um, yes, it has our name on it. Yes, I cannot deny that. Okay. Well, email me with your address and I will send one or two to you. I have no problem. So I need you to keep you busy right here and keep it. Okay, don't throw it away. Keep it, because you can take it to the exam, because since it is coiled, you are allowed to take it to the exam. So email me with your mailing address and I will do all my best to send one or two to you as soon as I can. As soon as I can. And I promise you, I will not send you any other things with it. Okay, no viruses, nothing. Okay, or no advertisement other than just our courses only. This is the only thing that if you are interested. Okay. The just email me with your mailing address, and I will do my best to send it to you. Okay. Um, the other thing that so the fatalities, yes, here it is. See handout. See the handout with two problems, and this handout will be attached to the rest of the notes that I'm going to. The the other problems that I included this morning, I told you that the time is the biggest enemy for me. Some problems, I probably saw them before, about mass diagram. Bunch of them, we can go over them. And also I have found the equations, and I have equations related to mass diagrams from another book, my construction book. I include these problems, not problems, these equations. You might need them. Okay. Equations, earth work mass diagram relationships and the equations. I can talk about all of them. But let me test your knowledge here very quick about the concept of the mass diagram, because you might see something in the morning and afternoon. Afternoon, yes, there is a high probability that that you might, assuming that a mass diagram is given like this, give you only one loop. So this station 1, station 2, station 3, station 4, 5, 6, 7, and 8. 8. 8 plus 0, 0, obviously a plus 0, 0, but this is the station, okay? And the station here is in feet. And the ordinate, as you know, which is the y-axis, is the cumulative volume, either cut or fill. This is the concept of the mass diagram that I talked about it before more than once. And let us assume, for the sake of discussion, that you have this scenario here. So this is 2,000, and this is 4,000, and this is 6,000, and this is cubic yard. Okay, and you are given a mass diagram, one loop like this. A loop consists of cut and fill. So let us construct it. It could be a straight line, it could be a curve. I will do it straight line. So as all of you know, that this is a high point, and this is called a loop. From here to here is a loop of a mass diagram. And obviously this is cut, which is a positive slope, and this is fill, which is negative slope. And the question there are many questions could be asked related to that. Um, number the direction of hole is forward, B, backward, C, both directions, or D, none of the above. None of the above. So this, it could be a question. Another question could be the overhaul in a station yard, is most nearly, I just made the problem, so I don't know, A, B, C, D, and I will wait for your answers and see what will be the correct answer. The overhaul in a station yard is most nearly. Overhaul station units or station yard. Okay, and let me give you about a couple minutes or so to answer these two questions, and after that I will jump. So this is question number one. Question number two. Question number three. Let me add another question here since you are fast. The average hole distance is most nearly the average hole distance A, B, C. Sorry, I don't have room here. C and D. Okay. Two stations, 3 stations, 4 stations, or 6 stations. Average hold distance in a station, either answer A, 2, 3, 4, this S, by the way, stations, and 6 stations, either 2 or 3 or 4 or 6. Hopefully that you can read my, and here I need a number here from you. Okay, so let's start with the question number 1. Number 1, direction of hole. The direction of hole. The direction of hole. Let me just draw a picture and come back to this, or draw an illustration. When the contractors, or when a contractor is working on a job, every distance that his equipment will travel, it costs him money. It costs him money because gas and time. So when you have the original ground, OG, and as a designer, you came up with some kind of a profile, you come up with some kind of profile for you, for the roadway you decided to do, maybe something like that. Let me make this darker a little bit. Here it is. For some reason, okay, the profile is like this. This is a profile grade, BG. There are many factors will dictate or will influence the selection of the profile grade. A lot of things, side distance, speed, and cost, and many factors. Let's assume that this is a profile grade of the proposed road. So we have points that we are intersecting the original ground, the OG, and since the profile grade, PG, this is a vertical alignment, as we call it, or a profile grade. Vertical alignment. Since we are here above the OG, this is fill. And since below the OG here is cut, all this is cut. And after that, we ended with another fill. So the contractor, this is a fill, and there's a cut here between this. So he needs to make the cut and transfer or transport this material from here to here. This is, he's going to hold it. And there is one famous concept. I don't discuss it with the transportation. I discussed with the construction group. It's called LEH. LEH. It is the limit of economic overhaul. How many stations, or what is the distance that the equipment can travel and you are still achieving the most economical way of moving the soil between the cut and the fill. So it is a business, and the contractor, they would like to get the equipment to travel the least distance and to achieve the maximum benefit of moving the earth within the project limits. So when he haul it, he would like to know exactly. So normally the station along the center line, normally this is a center line, by the way. Normally the profile grid is a center line unless it's divided highway and there is a reason that you have to. So normally this is a center line, normally. Center line of the road. And the center line of the road, it does have stations. A station, it's like 1 plus 0, 0, 2 plus 0, 0, name it, all the way to the end. Station is in feet or station is in meter. It's a distance in either case, and a distance measured along the center line. So we do have the direction of haul. It could be either forward or backward. So if the loop above the balance line, and this is the rule I need you to remember, if this is a station and this is 0, station line also call it a balance line because any horizontal line cutting a loop is a balance line. And if this is a cut and this is a fill and this is a loop, draw it. Could be a curve, so this is a high point. So this is a cut and this is a fill. So the contractor is responsible of taking the soil from the cut and move it that way. You will take the soil, the earthwork from cut to fill, from cut to fill. So in this case, this is a forward haul. Why forward? Because it is moving in the direction of increasing stations. And normally we start the job at the beginning and go along the increasing station, always like that. And the increasing station, by the way, they agreed that your grandfather and my grandfather, they agreed on this. This is the east and this is the north. If the facility is east-west, so the increasing stations will be this way. So if this is station 500, this 501, this is 502, 503, and so on. So increasing station this way to the east. If the facility, it is east-west. If the facility is north-south, if this is station 10, this may be station 11, this station 12, station 13, this station 14, and so plus 00, and so on. So also my grandfather and your grandfather, they agreed on that. So we need to respect their agreement and move in the direction. So this is standard notation that the direction of increasing station is called up station. It is to the east or to the north. It depends on the direction of the facility, and I need you to know. So when we are putting the mass diagram, we are starting whatever station, 10 or 15 or 1,000, whatever the beginning. Okay, so it could be 0, the beginning of the job starting here at 0. Okay, but this could be anything, as I mentioned. So this, if the loop is above the balance line or the station line, but if the loop is below the station line, this the forward haul is no longer be the case, but it will be a backward. So right now, if this is the station line and I have a loop below this where we have start with fill and after that we'll go to cut, positive slope and negative slope, as I mentioned before. This is This is a high point. And also, I need you to remember that a high point on a mass diagram is indication of a change from cut to fill. So this is C, cut to fill. But a low point, this is a high point. This is a low point. Okay. And again, we're still having our coordinates. Station is the x-axis or the abscissa, or the ordinate, and the ordinate, sorry, is fill cut along the ordinate, and this is cumulative, by the way. Cumulative, cumulative. I don't know, IVE or IV only, I can remember. Cumulative, Cumulative. Maybe I have E here. Cumulative, okay? Sometimes I challenge myself, okay? Cumulative, okay? So the if the loop is below the station line, so here we have a negative slope, which is F, and this is a positive slope, which is cut. So right now the contractor will do what? Will come here and take from cut to fill. So it's responsible to take all this cut here and move it this way. Move it this way. From cut to fill. So transport the material from here to here. So this is a backward hole. Backward hole. Okay. And I need you to remember a statement. It might be a target for a question. The area under the mass diagram, is defined as the hole or work. So the area, and this is one of the questions that you might be asked, the area under the mass diagram is in fact hole or work. I need you to remember this statement. It might help to answer some of the questions. So the direction of hole, it could be either forward or backward. It depends on the location of the loop, if it's above or below. So we have forward and backward as indicated, and backward because the stations also is going to be like that. Station 1, 2, 3. He can give you stations in reverse. So pay attention to that, please. Okay. This is something that I need you to be aware of. Going back to the 3 questions I wrote or I came up with. So obviously, this one here, after we just discussed, the direction of hole is, obviously, this is forward. The stations are increasing this way. So the contractor is going to take the cut, put it into the fill. So it is forward. So the answer is A. Okay, forward station or forward hole. Moving along the direction of the increase of stations. Okay, this is the first thing. The second question here, which is the overall in a station yard is most nearly. What is a station yard? A station yard. A station yard is a definition. Station yard is a volume, assuming this nice truck here. Okay, and this truck is hauling 1 cubic yard. The volume is 1 cubic yard. We load it with 1 cubic yard. And this truck traveled a distance of one station. One station could be 100 feet or 100 meters, as I said. Okay, and this volume, it could be 1 cubic yard or 1 cubic meter. Okay, it depends on the unit. So if this hauling truck is traveled or moved one station, so if you multiply the volume times the number of stations, we call it station yard. So if you multiply the volume that transported or hauled by the equipment times the number of stations or the distance, so this is a product, this is the unit cost that will be used to compensate the contractor. One of the methods, let me put it that way, to pay the contractors. Because it's not just only the volume, but also we look to the distance, because the distance involves time and gas and or gas and time and all these things. So the volume, yes, but if we would like to be very precise, the distance, it must be a factor in determining the unit cost and so on, because how far did he hold the material? So this is what is meant by station yard. So going back to question number 2, station yard for this, how many station yard that we should pay the contractor for this job? If this is a job, 800 feet, and a very nice and symmetrical. And so let us vote. We are a democratic country, and we're going to vote this coming November, as far as I know. Hopefully the virus will be gone by November. Otherwise, we'll be in big trouble. I don't know what will be the legality. If, God forbid, if the virus stays until November, can we do mail voting? I don't know. Absentee voting? I don't know. I don't know if it is written in the Constitution or is written in the somewhere. If in case of a pandemic like this, how the voting will be, because probably saw the news in some states for primaries. Some people they call for absentee or mail, but there was some kind of objection because there might be a fraud, and they insist the people, the governor, I can remember what state. I don't involve too much in politics because I am not a politician and I hate politics. I will be a very terrible politician because I cannot really with for to all politicians, but I don't. Anyhow, forget the politics. Let's go to mass diagrams. Yes, I don't know why I switch. Oh, yeah, I'm saying that let's vote. Okay. So, who give me the answer number 1 or answer A for this? Let me see. Give me a number. I'm not going to call your name. Don't worry. Give me a number. Okay, this here. And let me move the. Give me a number, just a number. I'm not. What is the overall quantity in a station yard? We need to vote. Okay, 12,000. Okay, 4, 8. Okay. Okay, so I have 12,000, and I have 4, and I have 8. And we agreed that one station yard is a volume of 1 cubic yard that carried by a truck. It will be hauled a distance, one station. If you multiply this times this, will give you the answer. If I know the volume and I know the distance that the truck will travel to dump this load, I multiply the distance times the volume. I need you to remember that. It is here station yard. Is a station yard. I draw a picture. Forgive me for my truck. Truck is not the best truck in the world, but anyhow, it is a truck to illustrate. My kids, one time I was teaching them something and they draw a truck like this. And the kids told me, Daddy, you cannot be an artist. I told me, I know that. I cannot be an artist for sure. I can't. I cannot be a politician and I cannot be an artist. This is another job I cannot really qualified for. I'm not qualified for. Okay, so here, this column here, cumulative, C-U-M-M-U, no, C-E-M-U. Oh my God, my spelling. Cumulative, C-M-U, cumulative, L-A-T-I-V-E. I think V-E, cumulative volume. So the okay. Yes, with E, cumulative. Yes, I was right at the beginning and I debated myself. So cumulative, C-U-M-U, cumulative. That's correct. So cumulative volume. Here it is. Let me add the E here, cumulative, because I put one E and without E, cumulative. Okay. So this is a cumulative, additive, CUM cumulative volume. So it is, I have 2,000, 4,000, 6,000 up to the peak here. So the volume, how we do it, the volume that will be generated, for example, this is a fill. So station 1, station 2, I calculate the volume. And we add the volume, this volume of the fill, added to the volume of the fill between station 0 and 1. So it's cumulative, additive. It's not the absolute. I need you to be aware of that. So that 6,000 cubic yards that shown here as a peak or the high point, this is the volume that has been generated between station 0 and or with the beginning of the job up to station 4, which is, and after that, so if you look to this job here, maybe let me draw something very quick. If this is the OG from the beginning to the end, let's assume that the OG is like this. For this job, this is the OG. So how can I draw, or how it looks like the profile grade? So the profile grade from here, the beginning, it is cut. That means my profile grade is all the way like that. It is cut. This is my profile grade. And from station 4, it start to be fill. So this my profile grade that will match this kind of, because I am here, I am below the OG up to this station, up to station 4. So this means that this cut, I need to remove all this soil and I will take it and dump it here because it is fill. So the contractor will take this and dump it here. This is why we call it forward. Okay. So a station yard is the volume that will be hauled over a distance, and we multiply both the volume and the distance. But the question is, the cut is happening at the beginning here between station 0 and 1. We have cut between 1 and 2. cut, and so on. So when the contractor start to move the soil from the earthwork from cut to fill, what distance are you talking about? The farthest point here or the closest point? Because here, between 3 and 4, I have a cut. This is very close. Here it is. But here is so far from here to here, all the way to here. And the fill also, the fill is happening from here to here. So they came up with center of mass. Okay? In order to eliminate this issue, or to solve this issue, sorry, not to eliminate, solve. So the average whole distance concept. The average whole distance. So they said, Mr. Mansour, we need to be fair. So if this is the OG, the one I was using for this problem, and this is the profile grade the hypothetical profile grade. Here you go. And this was station 4. And this is station 0 plus 0, 0. And this is station 8 plus 0, 0. And we said that, let me draw a little bit much better. This drawing is like a duck. Now, let's make it. Okay. Sorry if my drawing is a little bit. So this is cut, and this is fill, according to this. And we need a distance. So they said that where is the center of mass of the cut and the center of mass of fill? So CM and CM. And we are going to take this distance as CM is the center of mass. Center of mass. And CM is the center of mass. So if we are able to locate the center of mass of cut and the center of mass of fill, we take the distance between the two centers of mass as the average whole distance. Average whole distance, because we need to be fair with the contractor, because the contractor is hauling materials at different distances. Some of them are very close and some of them far away. The fill, some of them are close and some of them are at the end of the job. So they agreed on the center of mass. How can we do that? There are two ways to do it, which is a question number 3. How can we get the average whole distance? The average whole distance is the distance that's measured from the center of mass to the center of mass. So the average whole distance can be determined, which is the distance from the center of mass to the center of mass, CM to CM. This is CM, and this is the CM. Let me put the center of mass here, center of mass of cut and center mass of fill. There are two ways to do it. Graphically, and mathematically. Graphically and mathematically. Let's start with the graphically. Graphically, I will come to this ordinate and follow me, please. And I will bisect this. So from here to here all the way. So the middle point here, we call it midpoint, MP. Midpoint. 1, 2, 3, and 1, 2, 3. and I will come and draw a horizontal line parallel to the station line. This line, horizontal line parallel to this, that going through the midpoint, will intersect or intercept the cut and fill at 2 points. In fact, this is the center of mass of cut and this center mass of fill. If I come down, I found this is station 2 and this is station 6. So the average whole distance is 4 stations. So basically, any loop like that, you will come at the low point in this case, and come and draw a vertical line and bisect this vertical line by a midpoint MP and draw a horizontal line going through the midpoint of the ordinate at the low point in this case. This will intercept with this, So this is the center of mass of cut, and this is the center of mass of fill. The distance from here to here, if you go vertically, you know the station line. So this distance from here to here, we call it average whole distance. Average whole distance. Makes sense. Fair statement. Fair to both sides, to the owner and to the contractor. This graphically, mathematically, I can get the same thing by our saying that the average whole distance is equal to the area under mass diagram, which is the work, divided by the ordinate. In our case, what is the area? It is 1/2. What's the area of a triangle? It is 1/2 times 8 times the ordinate, which is 6,000, divided by the ordinate, which is 6,000. So this will cancel with this. This will give you 4 stations or 400 feet. Oops, 400, not 4,000, sorry. 400 feet, which is the same as we get here from a graphical solution. You take the 1/2 base times height. This will give you the volume, okay, divided by the ordinate, which is 6,000. We get with the same answer, okay? Obviously, the mathematically, for a parabolic shape like this or curved like this would be a little bit difficult, but you can approximate it. I believe they will give you 4 answers, okay? So here, problem number 3, the average whole distance is 4 stations. Answer is C. Now we will come to station yard. We say the station yard is the volume, which is 6,000 cubic yard, will be hold times 4 stations, which is average whole distance. So the answer here is 24,000 station yard. And this is the answer for question. So it is double this. Obviously, this is completely away. So unless probably the intent here or the intent here or the intention probably stations, but it is 6,000 cubic yards because this is how much the volume is generated. Okay, the total volume. This is the total up to this point. I have a volume 0. It start to cumulative, added until here. How many cubic yards I generated from the cut? Here it is. I start to cut all the way until here, crossing the cut to fill. How much volume was generated over all this? Where is my nice marker here? Oh, nice. How much is this? Let me highlight it here. This here. This is the total volume that is generated, and it will go and dump it into the fill, as you can see here. So I try to color as much as I can to make it easy for you to. So the answer for the overhaul in station yard is the number of yardage generated over the entire length of the job times the average hole distance. So I multiplied the 6,000 cubic yards, the 4 station, which is the average hole distance. Either you got it mathematically or you got it graphically. Both of them are acceptable, and even with the curve, I doubt that it will give you something in the 4 answers, even if you use the area. If mathematically you can, graphically you don't have it, you can use mathematical to approximate the area, and I can include some. And in fact, I have some problems. So I needed to be aware of that. I hope this is shed more lights on the mass diagram. I know if you cover it in school or not, and if it was covered in school, it is you still remember it or not. But I'm here to help you to refresh your memory about all these things, or your understanding. And please, after you receive them, let me know if there is anything else I can do to the equations. The one I was referring to, where is my sheet? My God, I have tons of sheets here. The equations that I will include also, and I don't know if I included in my transportation book or not, but I remember that whatever book I have next to me, because my books are spread everywhere in the office and at home, and some of them are here, some of them are there, and some of them I don't know. Okay, maybe in the car in the middle somewhere. So the first equation is the area under the mass diagram, or the mass diagram curve, or under the mass diagram only. It is a hole or work. The total hole distance is equal to overhaul plus the free hole distance if it is exist. The overhaul is equal total hole minus a free hole distance if exists. I can elaborate more on what is a free hole distance, because it could be a target also for a question. And a station yard overhaul is equal to the overhaul volume, here it is, time the overhaul distance, okay, minus the free hole distance if the free hole distance exists. In our case, we don't have that. So the overhaul distance, or the overhaul distance is it was 4 stations, if you remember, which is average hole distance, and the volume was 6,000. So 6,000 times 4, this is station yard overhaul. It's called the station yard overhaul. Okay. And the economic overhaul distance, it is the cost of the borrow over the cost of the overhaul. And finally, another equation related to LEH, which is explained here. This is very important for construction group, because this is the construction depth. But also maybe you might be asked about this indirectly for a transportation BM, but the LEH, the limit of economic hole, is economic overhaul distance plus the free hole distance. So I needed to be aware of that, okay? At the bottom here, there's something called load factor. Load factor is 1 over 1 plus a swell factor. And do you remember 1 over, what is 1 plus a swell factor, by the way? That was, sorry, 1 plus a swell percent. 1 plus a swell percent. Already I gave you the answer. 1 plus a swell percent is called a swell factor. A swell factor. And already I talked about this many times, and you maybe in the future you can see something like that. Okay, so those are the handouts here. Let me grab a question. I believe, let me make sure that I have all the materials here that I supposed to send to you immediately after I finish. Oh, I need to copy the my problem, the one I solved it with you guys, and I need to, yeah, this must be given just to make sure that, because I need to scan it before I forget, because my busy schedule, this and one more thing, I need to scan it and send it to you, which is, oh, the problem I solved it, yes. Where is my my Egyptian handwriting? Yeah, here it is. Yeah, I will scan this also, color, and you will get it. Okay, before I go home to eat something very quick and come back to construction group at 1 o'clock. Hopefully I can make it because the allergy is bothering me too much, but I will do all my best. At least I can spend whatever time spent with them this afternoon. You are very welcome. So let me put them in order and I will answer your question, my friend. I know one of you is raising the hand. Okay, now let me grab the questions you have, because I'm sure that you will have more questions because you will take all these notes. Please, okay, read us that, please send, I'm sorry, send us this page. Okay, I will, Alex. Okay, no problem. I thought that read, okay. Let me also, one of you is raising the hand. You are very welcome to interrupt me at any moment, but sometimes I wait until I finish my thought. Maybe the answer, let's go to New York. Hi, John, you are in the air. Go ahead, please. Hello?
Yeah, can you hear me, sir?
I can barely hear you. Can you raise your voice a little bit, please, or get closer to the microphone or to the mic?
I don't know if you hear me well. Yeah, thanks for all those.
Hello?
Hello, can you hear me?
I can hear you, but barely I can understand. Let me just, barely I can hear you.
Maybe I talk to you on the phone later on, sometimes.
Let me, go ahead. Your voice is right now is a little bit better. I can.
A little bit better right now? Can you hear me?
A little bit better. Go ahead and try to.
All right, so, okay. Yeah, so thanks for the lecture. I think next time we see it's going to be June, correct?
I am missing that also. I cannot really.
In June, we're going to, anyway, I'm going to send you an email, okay?
That's fine. That's fine. Okay, I'm sorry, my friend. There's something with the audio. I don't know. Maybe if you can shoot an email to me, it will be great. Okay. Yeah. Sorry, John, that I am not able to hear you very well. I try to work these problems. By the way, the signalized or signal warrants as much as you can, and every time or every mini exam I'll try to throw a problem. Let me go over this table very quick before we break for lunch or before I go and make the scanning. This is very close, or maybe the same problem, I can remember, because I have tons of problems over all these years. This is the one I sent it this morning. In order to complete the mass diagram problem, you need to complete this table. So stations are given, excavation and embankment are given, Normally, I assign and assign. This is negative for embankment, and this is fill, by the way, and this is cut. Excavation is cut, so the cut is positive, and fill is negative, as you know. So when I come here to this table here to create or generate the ordinate, this is a cumulative. This is the ordinate of the mass diagram. Ordinate of the mass diagram. So algebraic sum, you're adding this to this, which is if this is column 1 and this is column 2. So algebraic sum means column 1 plus column 2. This is what I meant. Okay. So you add 0 plus 0 will give you 0. And 3,000 and negative 1,000 will give you plus 2,000. And this is a plus 500. And this plus this is another plus 500. And this plus this a plus 1,500. And this plus this will give you 0. And this plus this is negative 1,500. And this plus this is negative 2,000. And this plus this is negative 1,000. And this plus this is negative 500. And this plus this plus 500. This is called the algebraic sum. After that, we are going to generate the ordinate. This is the y-axis of the mass diagram. This is the y-axis of the mass diagram. So if you add this to this, will give you 0. I will take this 0, add it to this, will give me a plus 2,000. I will take the plus 2,000, add it to this, and so on, 2,500. And already I did this before, so I will do it very quick. A plus 3,000, a plus 4,500. This plus this plus 4,500. And this plus this is a plus 3,000. And this plus this a plus 1,000. And this plus this will give you 0 plus 0, 0. And this plus this will give you negative 500. And this plus this will give you 0.00. This is the most important column in this table right now, because this is the column that will be used to, which is the y-axis. Here it is. And this is the one you are going to plot. I gave you the grid. I made the grid for you. You can plot it. I needed to construct the mass diagram, as I told you that. And we are lucky that because there is no any corrections, by the way. I have some problems where you apply shrinkage factor. You need to correct some volumes. Here, we don't need to. If you need more problems with corrections, yes, I have tons of them. Okay, 30 years of teaching, I have tons of questions, either from school, from students, or from the textbooks I used, or the exams I made. And I can't remember how many questions I have. But it's very, very important. So this is the ordinate here. So this is what I need you to do. Please do it. The commutative. Okay. So this is complete the table. This is an easy. And he said that the following condition of the earthwork operation for this highway or this expressway indicated as deficit or excess, or the job is balanced or insufficient data. Here I look to the last column and the last station. I ended with 0, 0. That means that is balanced. Balanced job. And this is always, which means cut equals fill. This is what I meant, or what is meant, sorry. Not what is, this is what is meant by balanced job. Cut equals fill. So the answer is C, as in Charlie. Okay. Please go over this, and I will be glad to go over them. Okay. I gave you another mass diagram. And here we have some, okay, the testing of the soil indicated that 1.15 cubic yard of excavation will yield 1.0 embankment. Because when we build roads or streets or highways or parking lots, whatever it is, you have embankment means fill. If this is a center line, so this is an embankment, we call it embankment, or simply it is a fill, and these are the side slopes. This point we call it HB, hinge point. This point here we call it CB, catch point. So in order to build this, so the contractor has to get some soil from somewhere. And he found Mr. Mansour. He has a nice piece of land next to him. He said, Mr. Mansour, I'm going to do something very good for you, win-win situation. I'm going to take this soil from here and dump it here to build this facility. And I'm going to, this is called, by the way, this method is called borrow bit volume method. We need to know that. He's going to dig a big hole for me and fill it with water. And he told me that he will put fish. So it is win-win situation. He's paying me for the earthwork and he's going to have a fish pond for me to put fish and I will make money. He's going to take the soil, okay? He's going to have some kind of nice trucks, okay? Carrying the soil from here and dump it here. And when they put the soil, by the way, they put it in layers. It's called lefts. We'll talk about compaction. Compaction is very important. We'll talk about it. I have a very nice section about compaction. When they put the soil, they put it in layers. Okay, 6 to 8 inches, sometimes 10 inches is called a left. Left. Okay, 6 inches, 8 inches, 10 inches, depends on the type of the soil. And compacted very well until we achieve the compaction. Do you remember a Proctor curve? You must remember the Proctor curve. Proctor curve, Professor Proctor. Okay. We have the moisture content here, and this is a dry density. Any civil engineer must remember this curve. Please remember this curve, okay? So as we increase the moisture content, the dry density will increase all the way until we get the maximum and they start to come down. This here, it does have a name, it's called OMC, optimum moisture content, OMC, and we must know that. We do this in the lab, by the way. We do a Proctor test in the lab, okay? Can talk about this later on, because I need to know that. I need to know this. This is gamma dry max. This is a maximum dry density can be achieved for this type of soil. We take a sample from this soil, by the way, not any soil. I need to know what soil he's going to use. Tell the contractor where you are going to get your soil, my friend. He'll tell me, oh, this location, Mr. Mansour has a nice land, and I agreed with him. I'm going to dig a hole for him. It's called borrow bed, and fill it with water after I finish, and put some fish, and they will make a lot of money. Okay. But the environmental people have to examine my site first to see if there is any, maybe I buried my grandfather here. I put him here. No, this is not a good borrow site. So the borrow site must be environmentally clean and declare by the environmental people. They will come and look to the history, who was the owner before me and before my grandfather, or so, and maybe somebody put some bones here. So we don't like to disturb my grandfather's bone, okay? So we have to find another location. But if it's environmentally clean and declared, in this case, they allow the contract to take the soil and put it here. So this gamma dry max, I know that. But when I start to put the lifts and compact the soil, can I achieve this? No, because this is a lab, a small sample and controlled environment. So we normally will live with 90% or 95%. You probably heard this term, 90% compaction. or 95. What 90% of what? Of this, of the lab. This is a lab work, because we cannot achieve 100%. It will be overkill and very expensive, and they found 95% is sufficient. No settlement will come later on. So we need to be, so this is what is meant, that 1.15 cubic yards excavated materials, this 1.15 cubic yard from here, it will build only 1 cubic yard here, because the soil will shrink. We know that. Do you remember that? And we talked about it. So I tried to go, here, the mass diagram is given, and he asks you for a lot of questions here. Please do your best, and I will do my best. And as long as we stay healthy, we can meet again. And and I wish you the best, but don't slow down, because I will be away for almost a month. Probably you notice that from our schedule. Let me see if I have the schedule here. It is on our website also, I believe. Where is the schedule? My webmaster put it somewhere here, or under bulletin board. I told him, do you have a bulletin board here or what? Here it is, under bulletin board, yes. And where this is a free 2 for 1. Where is the where is my they changed my God. Okay, no problem. I can get it from somewhere else. So the no, this is not. I was looking for the schedule. Let me. I think I can get it from here. Open, and where it is? Here it is. Yeah. So today is what? Today is 4/19. The next meeting will be June 6, early June, by the way, because the month of Ramadan is coming very soon. Next Friday, in fact, we'll start fasting, and I am not really sure I will be able to teach while I'm fasting. So I will skip this month. So until we meet again early June, and I can add another session if there is a need. So in addition, I believe I did not miss any session for transportation. I missed for construction and civil bridge, if I'm not mistaken. So, but I will be glad to add more sessions if there is any need for that. So probably I will skip, okay, because I'm not really sure I will be able. If I decided to add a session during Ramadan, probably heard about Ramadan, probably have some Muslim friends or something like that, talk about the fasting. So if I'm able, if I find that fasting the first week, I'm doing fine and I can survive fasting for almost from 5 o'clock in the morning until 7:30 in the afternoon. So almost 14.5 hours without eating, without drinking, without anything, just a fresh air only. And the fresh air without corona, please. Okay, so I hope that I would inhale only fresh air without any corona viruses, hopefully. Okay, I try to keep myself. Okay, so I hope that I'm doing my best here to help you guys. Just don't hesitate. So if I am able to add any session in the month of May, for sure I will not hesitate to do that. It depends. Okay, if I'm able to do that during my fasting. If not, we are going to meet again with the same ID, by the way. There is no change. The ID will still the same, okay, until we finish all these sessions. And thank you very much. I hope that you enjoyed what I'm trying to do, guys, to help you. And if there is anything that not clear, please let me know and I will do my best, okay? I will